Let's now look at some examples from sheet 2. Okay, we have the same familiar data and I've already named them. Make sure that you name the data. Now the first example is a hypothesis test about the average MPG. The question is whether the given sample data support the claim that MPG of cars manufactured by the 5 countries exceeds the standard of 22 miles. So now we have to first set up the hypothesis. Generally speaking, it is easier to set up the alternative hypothesis, which is the statement that needs to be proved. Here we want to prove whether the MPG exceeds 22 miles, so that's what should be in the alternative hypothesis. Exceeds 22. Put the number 22 in a separate cell. So then the null hypothesis will be the opposite of this, which will be less than or equal to 22. Now we need to gather some summary statistics so that the t-value can be calculated. So first is we want the sample size, and that is count MPG. We need the average value, so we compute average MPG. Then we need the standard deviation, so that will be stdev dot s for sample. Okay. Now the denominator for the t statistic is the standard error, s over square root of n. So let's find that. That will be s over square root of n. So that is the standard error of x bar. Okay, format these numbers as we go along. So now t can be calculated using this formula, where x bar is here and mu sub 0 is the value of mu in the hypothesis. So mu sub 0 in this case is 22. So we go x bar minus the value of mu in the hypothesis divided by the standard error. That gives us the value of t statistics calculated. Now the degrees of freedom is n minus 1. So that is n here minus 1. Next, is this a one-tailed test or a two-tailed test? Well, we look at the alternative hypothesis. If it is not equal to, then it is a two-tailed test. If it is other than not equal to, then it is a one-tailed test. So one-tailed test. Now, what formula should we use for p-value? Okay, so let's take a look. Okay, so here are the two t distribution functions. So for one-tailed test, we need to use t.dist.rt function. Okay. So t.dist.rt, and we must use the absolute value of the t always, absolute value of t, and then the second parameter is degrees of freedom. Okay, so that gives us a p-value of 0.67%. Now based on that, we can make a conclusion. Since p-value is less than alpha. Alpha, if it is not given, you assume alpha to be 5%. That's the default value. So p-value is less than 5%. Therefore, we reject the null hypothesis. Okay, what does that mean? The interpretation has two parts. One part is about the conclusion. The other part is about the p-value itself. Okay, I have prepared the interpretation, so we'll look at what that means. Okay, So the first part is we have sufficient sample evidence to conclude the average MPG of all automobiles manufactured by the 5 countries is greater than 22 miles, because we've rejected the null hypothesis, so we're going with the alternative. Now, but there is a probability that this conclusion will be false, and that is the p-value. So the probability that this conclusion is wrong, that is type 1 error, is 0.67%. Now let's look at how to do the same test using the t-table value. We just completed the test using the p-value. If the p-value is less than alpha, then we reject the null hypothesis. Now if we use the t-table value, now here is how we will select the t.inv function. T.inv function will give us the t-table value, and there are two versions. T.inv.2t will always give the two-tailed t value on the upper half. So you shouldn't divide alpha by 2. Okay, the t.inv.2t will take the alpha, divide it by half, and give you the top half t-table value. Whereas for a one-tailed test, we use t.inv. T.inv will always take the given probability as a cumulative probability. So if you want the left hand, the negative side of the t-value, so like here, if it is a one-tailed test with less than some value a, then we'll use t.inv of alpha. So you'll take alpha from the left tail and give you the t-table value for that. But if it is a hypothesis like this, mu greater than some value a, that is one-tailed test on the right-hand side, then the probability we need to provide for the t.inv function is the cumulative probability, which is 1 minus the tail. So it will be 1 minus alpha. 1 minus alpha is the cumulative probability, and then you use the degrees of freedom. So in this case, this is in our example, the hypothesis is one-tailed on the right-hand side, so we need to use this format of the t.inv function. So t-table value is t.inv and 1 minus the alpha value, and then the degrees of freedom. Okay, degrees of freedom, we have computed degrees of freedom right here. So this will give us the t-table value. Okay. So now we compare the t-table value with the t-calculated value, and you see this is, and you need to check the alternative hypothesis. So alternative hypothesis greater than 22, so which means our calculated t value must be greater than the t-table value for us to reject the null hypothesis, and that is the case. So we can say, since t calc, that is calculated t value, okay, is greater than t-table value, we reject H sub O. So let's subscript this, control 1, and select subscript. Highlight what needs to be subscripted, then press control 1. So highlight what needs to be subscripted, control 1 to open the format screen, and then subscript. Okay, so we've already interpreted the conclusion. So this is a second way of doing the same test. Instead of using the p-value, we use t-table value. And some of the problems that you will see in the chapter test will follow, will require you to look up the t-table value. And I suggest that you keep Excel open so you can find the t-table value from Excel and then use that in your chapter tests. Or you can use the t-table given in the back of the textbook also. Okay, you can figure that out, but I would recommend that you keep Excel open and use the Excel t.inv function to figure out the t-table value.